Hey everybody, welcome back. I hope you all are doing very well. So today, I'll answer this basic question that can you calculate distance from a velocity time graph, right? So many students were asking that, we know how to calculate displacement from a velocity time graph, but can we calculate distance also? So the answer is yes, we can calculate. And let's get to the root of this explanation, right? So whenever you write velocity, how do you write velocity mathematically? It is nothing but dx by dt, right? So velocity is nothing but dx by dt, or it is nothing but differential rate of change of displacement per unit time, right? And from there, if you know the derivations, we take dt with v, and integral v dt gives you the net displacement. Correct. Till here we know that integral v dt is nothing but the area under the velocity time graph, right? Correct. Fine. So this will give you the displacement. But how to calculate distance from the same thing? So if I go mathematically, if you see what is happening whenever you are integrating a function, right? So integral v dt, what is this giving you? This is giving you the area under the velocity time graph, right? And if I want to calculate distance, right, I need all the, I need all the areas, but only the positive part. What I'm going to say is, for example, let's say I have this is a body. It is moving, along the straight line. It goes ahead, then turns back. Correct. So it started from here, it started from this point, it went here, right? And then it turned back, it covered some distance. So now in this case, what is the displacement? Displacement is the shortest distance between the initial and the final point. So this is the displacement, right? So this is what the integration will give you. Why it will give you like that? Because you see, when you are going straight, it will give you a positive area. When it is returning back, the area will be negative, right? So in the velocity time graph, the area will come negative, so it will subtract it. So when you integrate, it will give you this much area only, because this is a positive area, this is a negative area, the net is this, right? But if I want to calculate distance, what is the distance in this case? Distance is the actual length of the path covered. So this is the initial distance, and when it returns, this is some more part of the distance. So this is some more part of the distance which we'll need to add. In the initial case, what we have done, we have subtracted it, right? So we just need to reverse the sign, right? So what will happen? How can you calculate? You can take the magnitude of the velocity, right? So integral of mod v dt will give you the distance, right? So integration of v dt gives you the displacement. Integration of mod, or the positive part of the velocity, if you integrate with dt, it will give you the distance. And in the case of velocity time graph, if you want to calculate the area, you calculate all the areas separately. Whatever areas are above the x-axis, they are already positive, but whatever areas are below the x-axis, they are negative. So you have to reverse that sign and add all of them up. That will give you the distance. I hope this is clear. Thank you so much. Have a very nice day. Bye.